So let's try an example here. So in this example, we're looking at some various different data collected where we've got for these 10 subjects, fat consumption compared with cholesterol level. And we want to determine, is there a correlation between those two variables? In other words, is there a relationship between how much fat is consumed and the amount of cholesterol? So for our Lin-Reg t-test, right, that's what we'll use to compute the test statistic, the R coefficient. Before we do that, let's just remember what our null and alternative hypotheses are. So these are always going to be the same. It's either rho is 0 when there's no correlation, or rho is not 0 when there is a correlation. Now, before we can compute the test statistic, I want to take a moment to just enter all these data into our calculator. So I'm going to take the fat consumption. We'll think of this as like our X list. So I'm going to enter all this data into L1. So take all the data here and enter that into one list. Make sure you're keeping it in the same order that we have here, so that, like, for instance, the 55 here matches up with the 180. So here, putting it in the correct order is going to be important. And then for the Y list, we'll enter all this data into L2. And again, it's important here that we keep it all in the same order so that each of these data match. Okay, and so once we do that, then we can run the Lin-Reg t-test. On these two lists, making sure that we're using rho not equal to 0 for the alternative hypothesis. And when we do that, we should get our test statistic of 0.9079. Okay, so take a moment to enter those data, run the Lin-Reg t-test, and make sure you can find where to get that test statistic. Okay, and in this case, we're using a 0.01 significance level. So the next thing will be to compare the 0.01 significance level critical value with this coefficient for R that we got as our test statistic. So like I mentioned before, we're going to not use the p-value method here, but we're going to focus on the critical value method. So let's look at that table of critical values again to help us find the one that's going to be useful for us here. And let's see, in this case we have a sample of 10 data. So here I'm going to look at a sample size of 10, and we're using a 0.01 significance level. So I'm going to look at the value here in our table. So that'll be the critical value. So let's put that here on our number line. So 0.6765 here, and we'll put the negative 0.765 over here. 0 would be there in the middle. And remember here, if our test statistic falls in some region above or below that critical value, then we're going to be able to reject our null hypothesis and say that there is a correlation. Otherwise, if it falls somewhere in between, then essentially the data is not strongly correlated enough for us to reject the null hypothesis. And to remind you, the critical value that we got before was 9.9079. And so we got a critical value that actually falls pretty close to 1 here. So our test statistic that we got was well within our critical region here. So it falls within that region there, so therefore we're going to be able to reject the null hypothesis and say that there is a correlation. So let's write that up in the next slide and then try and explain what perhaps our conclusion is that we can draw from this. Okay, so as we saw before, we got a high enough test statistic that we were able to reject the null hypothesis. And hence here, that means that we're going to say that rho is definitely not 0. So what conclusion can we make? Well, here, because it lied above the critical value on the positive side, we're going to say that there is a strong positive correlation here between fat consumption and cholesterol level. Now, whether or not fat consumption causes a higher cholesterol level is another question that has to be tested more carefully. But at least what this shows us here is that there is some relationship between these two variables, and it's a strong one because we got, remember our correlation coefficient was relatively high. It was pretty close to 1. So that tells us that we have a relatively strong correlation.